Hello and welcome to this lecture video. In this video I'm going to be talking about equivalent units and also how to calculate the cost per unit using weighted average process costing. So let's talk at a very high level about how to calculate the cost per unit. Okay? So again, if you were to go to Walmart and spend $100 to buy 10 t-shirts, how much on average did you spend per t-shirt? It's $10. How did you do that? You took the $100 total that you spent divided by the 10 t-shirts. So you took total cost divided by total units. And then that gave you the average cost per unit of $10. We're going to be doing something similar to this, and we'll be doing this for each department, and we'll also be doing it for each category of costs, so materials, labor, and overhead. But before we go into calculating some of the more details behind calculating this cost per unit, we need to talk about this denominator. How do we calculate how many total units? Well, with the example that I gave you, 10 t-shirts, that's pretty easy. You know you got 10 t-shirts. But in terms of process costing, figuring out this denominator, the total number of units, is a little bit more complicated. And so what we want to do is, if we're thinking about the mixing department, for example, let's say that we finished mixing 100 bars of soap. And then what we had is we had 50 bars of soap that we still hadn't finished mixing. So these are finished. And then this 50 is an ending work in process mixing. The M stands for mixing. But let's say of those 50, it's 50% complete. It's 50% complete. So if I have 50 bars of soap and they're 50% mixed, what that really means is that I have 25 full equivalent bars of soap. And so when I think about how many total bars of soap did I finished 125. Not 100, that's how much I totally finished. But I had 50, and then those 50 were 50% complete. So I also did 25 equivalent full units by taking that 50 times my 0.5 to give me 25. So my denominator, when I'm calculating my cost per unit, becomes 125 in this example using bars of soap. So that's at a very high level what we want to get to. Okay, so let's go through it in a little bit more detail to make sure you really understand. So you look at over here, if we're cooking, we're baking, and we have measuring cups. If we have 4 1/4 cups, how many equivalent full cups do we have? I could go 4 times my percent complete, 0.25, gives me 1 equivalent full cup. So if you have 4 little 1/4 cups, and you poured them all into 1 full cup, it would be up to the top, right? Full of water or baking soda or whatever ingredient you're using, right? Similarly, if we have 12 1/4 cups, what's the equivalent in terms of full cups? It's 3. How did I do that? 12 times my 0.25, right? Gives me my 3 equivalent full cups. And that's kind of that same idea that I was talking about right over here with the bars of soap. We have 50 bars of soap that we haven't finished mixing, but we've mixed half of it. That means we have 25 equivalent full bars. How did I do that? 50 times the percent complete. 12 times the percent complete gives me equivalent. Same idea. And so that's what I'm saying over here. So when calculating that average unit cost, which we know is total cost divided by total units, what we have to do is we have to convert the number of partially completed units in ending WIP to an equivalent whole number of units. Okay? how do we do that? We take the number of units in ending work in process, which means they're not done, times their percent complete. So for example, if we have 100 units in ending work in process, and they are 60% complete, that gives us 60 equivalent full units. We need to do that to calculate our average unit cost, because that becomes part of our denominator. And look over here, when we're calculating our average unit cost, this number right over here with our average unit cost for process costing is going to be equal to the number of units that are completely done, and when they're completely done, they're either moved to finished goods or to the next work and processing department. So it's going to be equal to the number of units that are completely done plus the number of equivalent full units in ending WIP. So it's going to be equal to our denominator when we're calculating our cost per unit will be equal to the number of units completely done plus the number of equivalent full units in ending work in process. And how do we figure out the equivalent full units in ending work in process? The number of units in ending work in process times their percent complete, which is what we're doing right over here. Now here's the thing. This is what makes it a little bit trickier, is that materials can be added at a different point in the production process than labor and overhead costs. Now labor plus manufacturing overhead equals something that what we call conversion cost. That's just a term. And also another term is that direct materials plus direct labor equals something that we call prime costs. Those are just terms that you need to know. Okay? So conversion cost equals labor, direct labor plus manufacturing overhead. Prime cost equals direct materials plus direct labor. Okay? Now here's the thing that I was saying earlier, is that if materials are added when production begins, all the materials are added at the beginning of the process. That means we are 100% done with respect to materials. It's kind of like if you're making lemonade and you buy lemonade from a mix. And let's say that I'm timing you on making the lemonade. And what you do is you put all the water into the jar, you put the mix into the jar, and then I say time. You're stopped. You're stopped. At that point, it's not finished, right? Because you haven't mixed the lemonade. But have you put in all the materials? Yes, because it's lemonade mix and water. At least that's the way I make lemonade. Okay? And so you are 100% done with respect to materials when I said stop. But you're not 100% done with respect to labor, because the labor cost is you mixing the lemonade. So just like that example, we can have similar examples in production process of other products. It's possible that we could add materials and conversion costs, or materials, labor, and overhead at different points in the production process. What that means is that our percent complete can be different for materials, labor, and overhead. And what that means, therefore, is that our denominator for calculating the average cost per unit can be different from materials, labor, and overhead. And therefore, we have to calculate the average cost per unit separately from materials, labor, and overhead, because they can be different percent completes, and they can be different percent completes because they can be added at different points in the production process. So if we look at this, if we say materials are added when production begins, whenever you see that, that means it's 100% done with respect to materials. And then we have 1,000 units in ending work in process. So 1,000 bars of soap. They're not fully done. But they're all done with respect to materials. But they're only 40% complete with respect to labor and overhead. What is our equivalent full units in ending WIP? Well, with respect to materials, it's 1,000 times 100% complete. 1,000 with respect to conversion, it's those 1,000 bars of soap, and they're only 40% complete with respect to labor and overhead, or conversion costs, 400 units. Okay? Again, why can this happen? It's because they're added at different points in the production process. Okay? So what this naturally means is because these percent completes are different, what that means is that we are going to calculate our average cost per unit separately from materials, labor, and overhead, because these percent completes can be different. Okay? And then what we'll do is we'll add up the average cost for materials, plus the average cost per labor, plus the average cost per overhead, and then that gives us the total average cost for making a single unit. Okay? So when we look at our denominator for calculating our average cost per unit, it's going to be equal to, just like I was saying with those bars of soap a few minutes ago, the units, the total number of units completed, plus the equivalent full units in ending work in process. So let's take a look at our example right here with McMillan Tire Company. McMillan produces tires that are used on small trailers. The month of June ended with 300 tires in process. This is 300 tires in ending work in process. They are 85% complete. These 300 tires are 85% complete with respect to materials and 50% complete with respect to labor and overhead, which is conversion. 2,500 tires were transferred to finished goods. That means they're done. Okay? The beginning work in process inventory is 65% complete with respect to materials, 45% complete with respect to conversion. This does not matter. We are using weighted average process costing. This doesn't matter. If we were doing first in, first out process costing, then it would matter. But whenever you see these in terms of this class, about beginning work in process inventory, 65%, it just doesn't matter. It's in there because I'm evil, because I'm testing to see, do you know what's relevant and what's not? Okay? Now we can determine the denominator to be used for calculating our average, omitted the term average, but that is the average cost per unit, or also called the cost per equivalent unit, or average cost per unit. And we'll do it for materials and conversion. So let's look at materials first. So if we look at the formula up here, we say units transferred plus equivalent full units in ending with. We had 2,500 units that were completed. When they're completed, they're transferred, and when they've been transferred, they're complete. Plus our 300 tires in ending WIP times our percent complete. They are 85% complete with respect to materials. And so what this gives us is 2,755 units, which would be our denominator for calculating our average cost per unit. Let's do the same thing here for conversion. We have our 2,500 units that were completed, plus our 300 tires in ending WIP, but they're only half complete with respect to conversion. That gives us 150 plus the 2,500, and that gives us our 2,650 units. So this would be used to calculate the average cost per unit for conversion. This would be used to calculate the average cost per unit with respect to materials. Now, on the next page, we're going to talk briefly about the cost per equivalent unit, which is our average cost. The way we calculate that, this is our average cost per unit, or also known as the cost per equivalent full unit. We take our total cost divided by our total units. This denominator right here is this, which is this. That's why we're going through and doing this, because we have to calculate our denominator for calculating our average cost per unit. In the next lecture video, I'm going to be talking about how to calculate the average cost per unit in more detail by going over this, and then also this again, and then doing some more additional problems. Thank you.